All right, ladies and gentlemen, we had some technical issues, which means we're going to redo all of our activities we did recently real quick. It's got all the steps here. The formula of the fuel, C3H8. What's it react with? O2. What's it give? CO2 and water. You know you need to know all that stuff. We're going to put coefficients in purple. We got 3 C's. We got 4 of those. That renders oxygen to be 6 plus 4 is 10. I'm throwing a 5 here and it's done. No fractions. Done. That's the answer to step 1. Step 2. Formula weight C3H8. Formula weights from the periodic table, units, grams per mole. I'm giving myself a tick mark. 3 times carbon. This is for C3H8. 3 times 12.01 plus 8 times 1.008 equals 3603 plus 8.064. Equals 44. Is that right? 44? Is that right? Yeah. 0.094. Grams per mole are the units on the periodic table. Okay. So formula weight for CO2. 2 times 12.01 plus 16.0. That's why I was so confused before. Not confused. They have the same molecular weight almost. Interesting, huh? Okay. Step 3. Grams to moles for C3H8. Grams was 24.62 right there. 24.62 grams. Oh, CO2, I got the number right, but I was in such a hurry, I put the 2 in the wrong spot. Sorry for that. Thank you. The young lady pointed out that I, while speaking and writing, put 2 C's and 1 O. That's not cool. The answer was right. 3. Grams to mole C3H8, 24.62 grams times 1 mole for every 44.0. Oh, no. Dr. Whitaker, it's C3H8. Well, that was 44. I was reading the first one. There. That's 24.62 grams of, I used the wrong one. This is the danger of not writing down what you're talking about. I should learn my lesson and do this every time. Please learn from my mistake. That's mole C, 1 mole C3H8. And this was C3H8, is that right? Yeah. Yeah. Good. Now I know I'm talking about the right substance. 24.62 grams propane, which is C3H8, times 1 mole of propane. Propane for every 44.094 grams equals. Does somebody have that? I hope. 0.5583. And we're just keeping all sig figs until my final answer. And now we are talking moles C3H8, which is told us in the steps to do. Mole C3H8, mole C3H8. Yes, we're well on our way. And then now we can talk about CO2. My question for you before we talk about CO2, how do we know from the question that the teacher's talking, that wants to know about CO2? It says, yes, 14.65 grams of CO2, carbon dioxide, is actually produced. Yeah. So I need to convert moles of propane to moles of CO2, not moles of water, not moles of oxygen, just CO2. So 4 we'll do in black. We'll do in, I don't know. Yeah, oh, you can't read yellow very well. Okay, I'll go with fat yellow. Yes. Give them what they want. This is step 4 in fat yellow. Times. It's going to switch to purple because it's coefficient time. I got to get rid of moles C3H8. I got to get moles CO2. Hey, moles and moles, both different substances. What am I using here? Uh-oh. What do I use to go from moles of C3H8 to moles of CO2? That's what I want to hear, coefficients in purple. And it's 3 moles of CO2 made for every 1 mole of C3H8. Where did I get that? 3 moles CO2 made for every 1 mole of C3H8 reacted. This is the only time you're using the coefficients in this whole exercise. Stop using coefficients after this. And we got 1.7. I don't know. What you got? That thing on your calculator times 3. 1.675050831. And now we're talking CO2. You know you're getting close to the end. It told us step 3, moles of C3H8 to moles of CO2. Mole C3H8, use the coefficients. These are coefficients. Well, you want to get picky, they're right there on the left. Mole CO2 to gram CO2. All right, let's do it. Step 4, go back to our normal thickness. We got 1.675057883 moles CO2. Grams per mole. Grams CO2 per mole CO2. We worked on that earlier. Formula weight. Thank you. Where did you get the numbers from? Periodic table. What are the units? Grams per mole. Good. And there are 44.01 grams of CO2 for every 1 mole. That's right here. And it's going to be over 100. Oh, no, it's not. Way off. No. Over 65.
73.
Okay. I got to give up some days. 73 point, give me it all.
719,29514.
Uh-oh. Gram per mole, gram per 1 mole?
No.
Mole of CO2?
Yeah, you saw this a 1 in that one, but there's not a 1 in that
Oh, I just lost it, didn't I? I don't think it's going to change her result. It will, won't it? Let's pretend she never said the 1 because we don't have time to redo anything. Yeah, me copying that 1 just disappeared forever. Yeah. And now I've got gram CO2. We are so close. We can do percent yield and call it. I've got, what does this represent? If you burned all of the 24.62 grams of C3H8, you would get this many moles of CO2, theoretically, which is equal to this many grams of CO2. Theoretically, these are both theoretical yields. Yes, he went to the question and got the actual yield of CO2, which always goes on the top. Percent yield, grams over grams is fine. 14.65 grams CO2 actually produced over, which of those 2 numbers that are in the red box gets used? Don't pick the wrong one. The bottom one has grams CO2, canceling. And it's 73, I'm going with the whole deal. She's still got the whole deal on her calculator, I think. Now I'm self-conscious about copying it. Okay. Looks like less than 25%, right? 28, 56. It's less than 20, maybe 20%. I don't know. Oh, I forgot the times 100. The percent times 100. Where can I get the clock? What you got? Yeah, we have to type it over. Say it again.
19.87, 26805.
And 4 sig figs. The question had 4 sig figs. Our periodic table has 4 sig. That's percent, dude. Percent. If you were to do what in the equation?
I said, would it be fine if we were to match the 460 with the 14.65 instead of writing the 4?
Well, if you had 4 sig figs here, and then again you rounded there, and then again rounded here, you're getting multiple rounding errors. Now, we don't have time now, but this question could have been done in one line. Much like activity 3 at the end, I did the alternate in one line. This is the same. So then you wouldn't have to worry about compound rounding because you never would have had to write these numbers down in the middle, right? And that's the end of today's videos.